Hey, ladies and gentlemen, good afternoon, good morning, whatever time of day is that this wonderful video is being brought to you. Let's use our good old fashioned Dixon Ticonderoga number 2 to work through these problems right here. Shall we? You ready? Let's get to it, shall we? All right, so first of all, this is all scientific notation. Scientific notation is just a shorthand way of writing really long numbers, really small numbers like this one, or very large numbers like this one. That's it. So let's start with this first one right here. It says, write the following numbers in standard form, which in the United States, that means non-scientific notation. That means writing the whole thing out. Well, this says times 10 to the negative 12th. What that really means, let's talk about this for just a minute. Times 10 to the negative 12th means that 8, oh, 12. 8.23 divided by 10 to the 12th. So that's a lot of zeros. That's a really, really small number. Whereas this one with a positive exponent, it's just multiplied out by a million or whatever, right? So what you got to do is you've got to move this decimal right here over, what, 12 times. All right, so let's see here. Because we want it to be times 10 to the 1th. So I think it's going to be, oh man, so we're going to have to go 1, 2, write it all out. Here's what we got. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros in front. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8, 2, 3. There we go. Boom, done. Hope I didn't miscount those. If I did, I apologize. We got the right idea right here. Whereas this one says times 10 to the 6, so we're going to move this 6 places. So this one's a little easier. We have 1, 2, 3. And we're going to have 3 more zeros after that. Right? So 1,023,000. All right, next up. It says write the following numbers in scientific notation. So scientific notation, let's talk about that real quick also. Scientific notation is a single digit number followed by a decimal and then whatever's after times 10 to some exponent, right? So this one's not in scientific notation because this is a 2-digit number. So I need to make this number smaller, 5.108. If I make that smaller, then this needs to be bigger in order to keep it the same exact value. Negative 11 is bigger than negative 12. I moved it one decimal to the left, which means I'm going to have to make this larger. Now this one I'm going to have to make this number smaller. I'm going to have to make this number bigger. So it's going to be 2.5, right? Times 10 to the, since I made this number larger, right, I have to make this number smaller so it's still worth the same value. I moved it over 1, 2, 3 places, so that's going to be 4. It was a 7, now it's a 4. Moved it 3 places, take 3 away from the 7, right? Okay. Next up, Buttercup. Here's what we got to do. We need to multiply these two numbers together, right? Um, and then we have to write our answer in scientific notation. So here's the first thing. When I multiply 10 to the third times 10 to the seventh, that's 10 to the 10th, right? And when I multiply these two numbers right here, 3.21 times 4.998, oops. Oh, sorry about that. You couldn't see that. Let me try that one more time just to make sure. 3.21 times, this making sure is a good idea when you're taking a test. 998, because you can do stuff like that really easy. So equals, yes, 16.04358. So that would be 16.04358 times 10 to the 10th, right? Problem is, that's not in scientific notation. I need to make this number a little smaller. So I'm going to make 1.06435, 5a, whatever. We could round that at some point, times 10 to the, now look, since I made that number smaller, I have to make this number larger, times 10 to the 11th. Now, next one we're adding, okay? Man, so when you add these, let's see here. How do we want to do this? We've got a couple ways. These are not like terms right now. Do you see? We can multiply when things are unlike terms, but we cannot add if things are unlike terms. We have a 10 to the 7th, we have a 10 to the 3rd. So what would be a good idea is to make this a 10 to the 7th or make this a 10 to the 3rd. I'm going to keep this one a 10 to the 7th, 3.21 times 10 to the 7th, and I'm going to make this a 10 to the 7th. If I want this to be a 7, it's going to be larger. right? That means this has to be smaller. So what I have right now is 4.998. And I need to move this 4 places, right? So 1, 2, 3, 4. So it's going to be a dot, 1, 2, 3. So it's going to be 0.000499 times 10 to the 7th as well. They're both times 10 to the 7th. So here's what we got. We got 3.21, 04998 times 10 to the power of 7. Dang, look at that hotness. That's just fantastic. Okay, now, no calculator. It says, without a calculator, perform the following calculations. So we've got to add these two. We're going to do the same thing. You see, these are not like terms right now. We cannot add them the way they are with scientific notation. Now, we could write the whole thing out and then add them and then put it back in scientific notation. But especially depending on what numbers they give you, that might be Ooh, that might be a big task. That might take you a ton of time. What's easier is either to make this a 4, a -4, right? Or this a -3. To make them the same is what we have to do. So I'm going to make this a -3. So here's what I got. I got 6.23 times 10 to the -3rd, right? Now this one is times 10 to the -4th. If I want to make that -3, it makes it smaller, makes this smaller, which is going to make this one sorry, if I make this a -3, it's bigger, which means I'd have to make this smaller. So I have to do that. 0.42. 0.42 times 10 to the -3rd. Okay, so from -4 to -3, that gets larger, which means this has to get smaller, which means I move it like that. So 6.65 times 10 to the -3rd. Boom, done. Next up, Buttercup. I've got to multiply these two together. So look at this. 10 to the 5th times 10 to the 3rd. That's going to be 10 to the 8th. Because when the bases are the same and you're multiplying, you add those exponents, right? And then 3.9 times 1.2. For the sake of time, we're going to go ahead and knock this out real quick. That's 4.68. See? 8, 1, carry a, 2, 6, 7, 0, 9, and 3. So 4.68. 4.68 times 10 to the 8th. Boom, done. Now that's already in scientific notation because we have a single digit, right? And then followed by a decimal. So boom, done. Now this one, squared. 1.1 squared. So 1.1 squared is 1.21, right? 1.1 squared. And 10 to the -3rd squared is 10 to the -6. Boom, done. So hope it's been helpful. Our Dixon Ticonderoga number 2, trusty old great pencil, saved the day again. Hope you guys are having a wonderful day. Be safe out there. Until next time, I'll see you later.